Quadratic equations. We have already studied different types of polynomials. One type was the quadratic polynomial of the form ax squared plus bx plus c, where a is not equal to 0. When we equate this polynomial to 0, we get a quadratic equation. Quadratic equations come up when we deal with many real-life situations. For instance, suppose a charity trust decides to build a prayer hall having a carpet area of 300 square meters with its length 1 meter more than twice its breadth. What should be the length and breadth of the hall? Solution: suppose the breadth of the hall is x meters, then its length should be 2x plus 1 meters. Now, area of the hall is equal to x into 2x plus 1 meter squared, that is equal to 2x squared plus x meter squared. So, 2x squared plus x is equal to 300, given. Therefore, 2x squared plus x minus 300 is equal to 0. So, the breadth of the hall should satisfy the equation 2x squared plus x minus 300 is equal to 0, which is a quadratic equation. Many people believe that Babylonians were the first to solve quadratic equations. Greek mathematician Euclid developed a geometrical approach for finding out lengths, which in our present-day terminology are solutions of quadratic equations. Solving of quadratic equations in general form is often credited to ancient Indian mathematicians. In fact, Brahmagupta CE 598 to 665 gave an explicit formula to solve a quadratic equation of the form ax squared plus bx is equal to c. Later, Sridharacharya CE 1025 derived a formula now known as the quadratic formula, as quoted by Bhaskara too, for solving a quadratic equation by the method of completing the square. An Arab mathematician, Al-Khwarizmi, about CE 800 also studied quadratic equations of different types. Abraham Bar Hiya-ha-Nasi, in his book Liber Embadorum, published in Europe in CE 1145, gave complete solutions of different quadratic equations. In this chapter, you will study quadratic equations and various ways of finding their roots. You will also see some applications of quadratic equations in daily life situations. A quadratic equation in the variable x is an equation of the form ax squared plus bx plus c is equal to 0, where x is a variable, a, b, c are real numbers, and a is not equal to 0. For example, 2x squared minus 3x plus 1 is equal to 0, 4x minus 3x squared plus 2 is equal to 0, and 1 minus x squared plus 300 is equal to 0 are quadratic equations. In fact, any equation of the form px is equal to 0, where px is a polynomial of degree 2, is a quadratic equation. But when we write the terms of px in descending order of their degrees, then we get the standard form of the equation. That is, ax squared plus bx plus c is equal to 0, where a is not equal to 0 is called the standard form of a quadratic equation. Quadratic equations arise in several situations in the world around us and in different fields of mathematics. Let us learn to represent the following situation mathematically. John and Jivanti together have 45 marbles. Both of them lost 5 marbles each, and the product of the number of marbles they now have is 124. We would like to find out how many marbles they had to start with. Solution: let the number of marbles John had be x. Then the number of marbles Jivanti had is equal to 45 minus x, since the total number of marbles is 45. The number of marbles left with John when he lost 5 marbles is equal to x minus 5. The number of marbles left with Jivanti when she lost 5 marbles is equal to 45 minus x minus 5, that is equal to 40 minus x. Therefore, their product is equal to x minus 5 into 40 minus x, that is equal to 40x minus x square minus 200 plus 5x, which is equal to minus x square plus 45x minus 200. So, minus x square plus 45x minus 200 is equal to 124. Give that product is equal to 124. In other words, minus x square plus 45x minus 324 is equal to 0. Multiplying by minus 1 throughout, we get x square minus 45x plus 324 is equal to 0. Therefore, the number of marbles John had satisfies the quadratic equation. X square minus 45x plus 324 is equal to 0, which is the required representation of the problem mathematically. Check whether the following are quadratic equations. 1, x minus 2, the whole squared, plus 1 is equal to 2x minus 3. In LHS, x minus 2, the whole squared, plus 1 is equal to x squared, minus 4x plus 4 plus 1, that is equal to x squared minus 4x plus 5. Therefore, x minus 2, the whole squared, plus 1 is equal to 2x minus 3 is same as x squared minus 4x plus 5 is equal to 2x minus 3. Therefore, we get x squared minus 6x plus 8 is equal to 0. It is of the form ax squared plus bx plus c is equal to 0. Therefore, the given equation is a quadratic equation. 2. X into x plus 1 plus 8 is equal to x plus 2 into x minus 2. In LHS, x into x plus 1 plus 8 is equal to x square plus x plus 8, and in RHS, x plus 2 into x minus 2 is equal to x square minus 4. Therefore, x square plus 8 is equal to x square minus 4. That is, x plus 12 is equal to 0. It is not of the form ax square plus bx plus c is equal to 0. Therefore, the given equation is not a quadratic equation. Solution of a quadratic equation by factorization. Consider the quadratic equation 2x square minus 3x plus 1 is equal to 0. If we replace x by 1 on the LHS of the equation, we get 2 into 1 squared minus 3 into 1 plus 1 is equal to 0 is equal to RHS of the equation. This means that 1 is a 0 of the quadratic polynomial 2x square minus 3x plus 1. In general, a real number alpha is called a root of the quadratic equation ax squared plus bx plus c is equal to 0. A is not equal to 0 if a alpha square plus b alpha plus c is equal to 0. We also say that x is equal to alpha is a solution of the quadratic equation, or that alpha satisfies the quadratic equation. Note that the zeros of the quadratic polynomial ax squared plus bx plus c and the roots of the quadratic equation ax squared plus bx plus c is equal to 0 are the same. Find the roots of the quadratic equation 6x squared minus x minus 2 is equal to 0. Solution: we have 6x squared minus x minus 2 is equal to 6x squared plus 3x minus 4x minus 2, that is equal to 3x into 2x plus 1 minus 2 into 2x plus 1, which is equal to 3x minus 2 into 2x plus 1. The roots of 6x squared minus x minus 2 is equal to 0 are the values of x for which 3x minus 2 into 2x plus 1 is equal to 0. Therefore, 3x minus 2 is equal to 0, or 2x plus 1 is equal to 0. That is, x is equal to 2 by 3, or x is equal to minus 1 by 2. Therefore, the roots of 6x squared minus x minus 2 is equal to 0 are 2 by 3 and minus 1 by 2. Solution of a quadratic equation by completing the square. Let us now study another method of solving quadratic equation. Find the roots of the equation 5x squared minus 6x minus 2 is equal to 0 by the method of completing the square. Solution. First, make the coefficient of x square a perfect square by either dividing or multiplying it with the same number. Here, coefficient of x square is 5, which is not a perfect square, so multiplying throughout by 5 we get 25x squared minus 30x minus 10 is equal to 0. 25x squared can be written as 5x the whole squared. For second term, we multiply 2 with first term 5x multiplied by 3 to get 30x. Now the square of 3 is added and subtracted to balance the equation, and then finally minus 10 is equal to 0. Now taking square root on both sides, we get root of 5x minus 3 square is equal to root 19. Therefore 5x minus 3 is equal to plus or minus root 19. 5x is equal to 3 plus or minus root 19. That is, x is equal to 3 plus or minus root 19 upon 5. Therefore, the roots are 3 plus root 19 upon 5 and 3 minus root 19 upon 5. The roots of ax squared plus bx plus c is equal to 0 are minus b plus root of b squared minus 4ac upon 2a and minus b minus root of b squared minus 4ac upon 2a if b squared minus 4ac greater than or equal to 0. If b squared minus 4ac is less than 0, the equation will have no real roots. Thus, if b squared minus 4ac is greater than or equal to 0, then the roots of the quadratic equation ax squared plus bx plus c is equal to 0 are given by minus b plus or minus root of b squared minus 4ac upon 2a. This formula for finding the roots of a quadratic equation is known as the quadratic formula. A rectangular park is to be designed whose breadth is 3 meters less than its length. Its area is to be 4 square meters more than the area of a park that has already been made in the shape of an isosceles triangle with its base as the breadth of the rectangular park and of altitude 12 meters. Find its length and breadth. Solution. Let the breadth of the rectangular park be x meter, so its length is equal to x plus 3 meter. Therefore, the area of the rectangular park is equal to x into x plus 3 meter squared is equal to x squared plus 3x meter squared. Now, base of the isosceles triangle is equal to x meter. Therefore, its area is equal to half into x into 12.
That is equal to 6x meter squared.
According to our requirements, x squared plus 3x is equal to 6x plus 4. That is, x squared minus 3x minus 4 is equal to 0. Using the quadratic formula, where a is equal to 1, b is equal to minus 3, and c is equal to minus 4, we get x is equal to 3 plus or minus root 25 upon 2, that is equal to 3 plus or minus 5 upon 2, is equal to 4 or minus 1. But x is not equal to minus 1 as the breadth cannot be negative. Therefore, the breadth of the park is equal to 4 meter and its length will be 7 meter. Nature of roots. The roots of the equation ax squared plus bx plus c is equal to 0 are given by x is equal to minus b plus or minus root of b square minus 4ac upon 2a. If b square minus 4ac is greater than 0, we get two distinct real roots, minus b by 2a plus root of b square minus 4ac upon 2a and minus b by 2a minus root of b square minus 4ac upon 2a. If b square minus 4ac is equal to 0, then x is equal to minus b by 2a plus or minus 0. So x is equal to minus b by 2a. So the roots of the equation ax squared plus bx plus c is equal to 0 are both minus b by a. Therefore, we say that the quadratic equation ax squared plus bx plus c is equal to 0 has two equal real roots in this case. If b square minus 4ac is less than 0, then there is no real number whose square is b square minus 4ac. Therefore, there are no real roots for the given quadratic equation in this case. Since b squared minus 4ac determines whether the quadratic equation ax squared plus bx plus c is equal to 0 has real roots or not, b square minus 4ac is called the discriminant of this quadratic equation. So the quadratic equation ax plus bx plus c is equal to 0 has 1. Two distinct real roots if b square minus 4ac is greater than 0. 2. Two equal real roots if b square minus 4ac is equal to 0. 3. No real roots if b squared minus 4ac is less than 0. Find the discriminant of the equation 3x squared minus 2x plus 1 upon 3 is equal to 0, and hence find the nature of its roots. Find them if they are real. Solution. Here, a is equal to 3, b is equal to minus 2, and c is equal to 1 by 3. Therefore, discriminant b squared minus 4ac is equal to minus 2 squared minus 4 into 3 into 1 by 3. That is, 4 minus 4 is equal to 0. Hence, the given quadratic equation has two equal real roots. The roots are minus b by a, minus b by a, that is 2 by 6, 2 by 6, that is 1 by 3, and 1 by 3.